Okay, this is the procedure for measuring a solid. We've been looking at these geometric solids. We're going to measure the volume of this solid, and then we're going to displace it and see how much water it actually displaces, and compare the volume of water with the volume that we calculated. I'm going to use a protractor to do my measurements, and I'm going to use this metric scale, or centimeters, here on the top part of the protractor. We're going to be measuring in centimeters because our graduated cylinder measures in millimeters. I'm sorry, excuse me, milliliters. I know that 1 cubic centimeter is equal to 1 milliliter. So I'm going to figure out the volume of this in cubic centimeters. So I take a few measurements. I'm going to measure, for this particular geometric solid, the length, width, and height. All three: length, width, and height, or length, width, height. It doesn't matter the orientation as long as I maintain the orientation. These are the numbers that I came up with and my calculation for the volume of this particular solid. My length of 3.3, my width of 3.8, and my height of 4.5. I take length, width, and height, and I multiply them all together, and I came up with 56.4 centimeters. 56.4 centimeters. So now, let's use a procedure that I came up with to measure the volume. I've got 3 cups here. One cup is about 2/3 full. It's deep enough that I know that this solid will go into and submerge and not stick out of the water. Next, I have an extra cup with a little bit of water. And then I have a discard cup for extra water. And I'll show you exactly what we're going to do. The first thing I'm going to do is mark my initial water level. I'm going to make the mark so that the top of the pen is at the water level line. You could do the bottom of your pen mark, but I'm going to do the top of my pen mark is at the water level line. Then I'm going to take my solid, I'm going to submerge it, and I'm going to have to do something like with a pen, hold it down so it's just barely under the surface without getting my pen or my finger into it, which would then displace more water. So really what I want to do is be as careful as I can. This thing is going to float because it's wood, but I'm going to push it down just so that everything is below the surface. It's right there. So now I have an object that is completely below the surface with hopefully nothing else in the water. And I'm going to mark the next water level. Now I can let this thing come out of the water. Okay, the next thing I'm going to do, I now know how far the water displaced when I put the volume in. I'm going to take some water, and I'm going to very carefully fill with the amount of water from my additional cup up to the top of that next line. So I've just put the same volume of water into my cup. That was just a little too much. So let's pour a little bit back. And a little bit back. So now I've got almost exactly as much water added as this displaced. Now I can discard the rest of my water so that I have an empty cup. I've got an empty cup. I'm going to transfer the water from my full measured cup. I'm going to transfer all of it into my empty cup, and you'll see why in just a second. I think it's going to be easier for us to get an accurate measurement if we do this. So now my original marked cup is empty. I take that a cup of water. This is the same amount of water as was in the empty cup. I'm going to fill it up to the bottom line so that the only water left in this cup is the exact same volume as this cube. I'm sorry, it's not a cube, it's a prism, rectangular prism. So I'm going to very carefully fill until I reach the water level of the bottom mark. Right there. Now I have the amount of water that's equal to the volume of this prism. Don't care about this water anymore. I only care about this water. So here's my discard cup. I now take my graduated cylinder, and I'm going to carefully fill my graduated cylinder. Notice it only goes up, you may not be able to see, but it only goes up to 25 milliliters. I calculated that this thing would be about 56. So I'm going to need to fill this graduated cylinder up to a mark, dump it, and then fill it again. I'm not going to try to fill to exactly 25, because if I do that, if I overfill, I'm going to have to pour some back. So I'm just going to fill up somewhere into the low or high teens or lower 20s, and then I'll discard, and I'll keep track of exactly what I did. Okay, so reading the bottom of the meniscus, I poured to a level of 21, looks like 20, almost exactly 22. So I can write that down, 22.0. Then I will discard it. Then I will do it again. And this time I filled up to, looks like 21.8. 21.8. So I'm keeping track of my numbers here. Whoop, sorry, I can't see it. Plus 21.8. I'm actually writing backwards, just so you know, it's a mirror image. And I'll discard that, and one last time. Reading to the bottom of the meniscus, I have, looks like 15.2. 15.2. Plus 15.2. Now I can add all of these up, and it will give me the volume that I calculated using the actual displacement. So that looks to me, using my calculator, (22) plus 21.8 plus 15.2. I calculated a volume of 59. The volume I calculated was 50. That's terrible looking. 59 cubic centimeters. Centimeters cubed. 59 cubic centimeters. My guess was 56. If I divide 56.4, if I take 56.4, and I divide it by 59, I'll get a percentage of 95%, 0.95. I am 95% correct. So I am within 5% of the actual volume that I calculated and the volume that I measured. Okay, that's the procedure. Ready, go.